Hello everyone, today we are calculating number 38 from chapter 16 from RChibbeler Static and Dynamic 14 edition. So the problem requires x to find the magnitude of velocity and acceleration at point B at the instant of 6 radian angular position. So we'll start writing down the given facts that we knew from here. So it's the sphere start from red, so it means omega naught it's 0 radian per second, and theta is 0 degree at initial position, so it's also 0 radian. And the problem requires us to determine at the instant of 6 radian, so it's 6 radian is what we require, and alpha is equal to 4 theta plus 1 in terms of angular position, radian per second square. So from here we will apply the theory from equation 16.4, which is a relation of angular position, angular velocity, and angular acceleration. So it's alpha delta theta is equal to omega delta omega. And since they have differentiation forms, we will need to use the integration to exclude these values. So it's omega delta omega by delta theta is equal to alpha, and alpha is equal to 4 theta plus 1, and then delta theta will move to this side, omega delta omega, and we will take integration on both sides. So for us, the result of integration is omega becomes omega squared by 2, and the 4 theta becomes 4 theta squared by 2 plus theta, and then plus c is as a constant. So we will eliminate the fraction, so it's omega squared equal to 4 theta squared plus 2 theta plus constant still became constant. So this is simplification form that we derive from equation 6-4. So we will have to start with, like, at the start position, the omega naught is here is 0. So we will apply this again. So at start it is omega naught equal to 0. So that is why theta naught equal to 0 as well. And applying this equation, there will be like c equal constant equal to 0. So they will only have omega square equal to 4 theta square plus 2 theta. And again, at the stage of theta equal to 6 radian, it will be omega equal to, it's omega square equal to 4 6 square plus 2 into 6, and then omega value is equal to 12.49 radian per second. So now we have omega value. Since the angular velocity is the same at any point, this is the omega value at point P. So we move to the next page. So point B, omega P is equal to 12.49 radian per second. So in fact, we also know alpha P because it is the same at any point in the sphere. So it's alpha P is also equal to, alpha equal to 4 into 6 plus 1, it's 25 radian per second square. So from now we still need to find the magnitude of velocity and acceleration at point B, and we only have the angular values now, so we need to find the distance from the here is the, this is the axis, so this is a sphere, so we will need to find the distance from the axis to the P point, which is this. which is this part. So we will draw a circle down here, and then so the angle is 30 degree and the radius is 8 inches. Okay, and this radius is 8 inch. What we need to know is this distance. So it is this hypotenuse is still the radius, so we'll find this from the ratio, and let's name this x. So x equal to x, and then this is y. Okay, x and y. So is x equal to this is the 60. So is the sine 60, and this is 8. So the value is 6.928 inch that we need to use to find velocity and acceleration. So the RB value is 6.928 inch. And then that's why V equal to omega P RP 12.49 radian per second into 6.928 inch, and that's equal to 86.531 inch per second. And we can also change this to like feet, so which is equal to 7.211 feet per second. And the angular acceleration value in tangential component, so it's AT equal to alpha P RP. Alpha P is 25 radian per second square, and then RP is 6.928 inch, and that's equal to 173.2 inch per square, and that is equal to 14.43 feet per second square. And again, for normal acceleration, it's omega square RP, so it's 12.49 radian per second the whole square, and 6.928 inch, and that's equal to 1080.77 inch per second square, and that is equal to 19.06 feet per second square. And for the total magnitude of the acceleration, it's the combination of AT squared plus AN squared, and that is equal to 91.21 feet per second square. So this is it about this problem. We have got the velocity value and acceleration value at point B. Thank you.